Now the next concept I'd like to introduce is that of variables. And what variables are containers or spaces in memory for storing different data values. Now the analogy that is very frequently used for variables or storing things in memory is that of lockers, because it's a pretty good metaphor for what's going on when we create a variable. Every variable has three things. It has a name, a type, and a value. The variable name would be analogous to a locker number. It's something that identifies the variable. The type is something a little more internal in Python, as we've discussed, but based on the type of the data object, that may change the size of the storage locker. More simple or primitive data types might be smaller, where more advanced data types might be larger. And the third attribute, which is the value, that would be analogous to what goes in the locker. A few other words you'll hear regarding variables when I'm talking, or just when people are speaking about computer programs more generally, is that a variable is given its name only one time, and when that happens, we say that we're declaring a variable. However, we can change the value of the variable repeatedly as much as we'd like, and we say we are reassigning the value of the variable in that situation. Now there's an art to naming variables in computer science, and perhaps the governing principle of naming variables is that you should name them in helpful and descriptive ways. This helps other people read your code, and so this should be the number one governing rule of naming variables. There are, however, some syntax rules that we also need in order to name things properly, and that is that we can only use alphanumeric values and the underscore character in order to name our variables. It's fairly clear why we might want alphanumeric options for naming our variables. The underscore is because we're not allowed to use spaces, and so you typically would put an underscore in a variable name where you might want a space. Another option for that is to name your variables in what's called camel case, and I've shown an example of that over here, which is basically any time you change from one word to the next word. Because you're not allowed to put a space there, if you don't want to use an underscore, one thing you can do is capitalize when you're changing from one word to another. And people who use that convention of naming their variables will often say that they're using camel case. Although numbers are allowed for within a variable name, you cannot start a variable name with a number. So you cannot say something like 1 radius, you would have to say something like radius 1. And last but not least, variable names are case sensitive, much in the way that passwords are on a computer. So that covers some of the technicalities and the syntax regarding naming variables. Next, what I'd like to cover are some specifics of the floating point data type. The floating point data type is a built-in data type that holds numbers with a decimal point. So I'm thinking of things like pi, 3.14159, 1/3, 0.333, etc. One particular instance of a data type might be called a float, and in fact, if I were to go into Python and use that type command and ask for the type of pi right here, it would tell me that it is a float. So floating point data type and float are the same thing. Any data type comes with operations that are valid on instances of that data type, and the operations for floating point data type are the things that you might expect them to be, which are standard arithmetic operations: addition, subtraction, multiplication, division. And what's nice about Python, which is different from some other programming languages, is that it has a built-in shortcut for exponentiation, where it uses 2 multiplication signs in a row. So as an example, if I wanted to compute 2 to the 5th power in Python, I would write 2 ***5. That would give me an answer of 32. I've also included some examples here of how we make declarations. We'll talk about this more in a later video, but the first thing I do is create the name that I want for the variable. Again, I'd like it to be descriptive. If the thing I'm defining is 3.14159, I'd like to call that value pi. So the notation for declaring a variable is variable name is equal to the value we want to store within that variable. Similarly, we've defined radius here to be equal to 4, and it is okay to define a new variable. Here I've defined a new variable called circumference, and the value that I want it to have is 2 times pi times the radius. That will put a value of 2 times 4 times 3.1415926 inside the variable circumference. And just as one more example of using that exponential notation, we could create a variable called area whose value is pi times the radius squared. Now the last thing I want to cover in this video is the order of the operations that we have for our floating point data type. Now the order of operations is just what you learned in school, but because there's a lot of confusion floating out in the world, I want to make sure that we're all on the same page. Now, I don't think that your social media feed looks exactly like mine, but something about having a PhD in mathematics means that people like to share this kind of post with me all the time and ask my opinion. And typically what happens is that somebody puts up a problem like this and asks you to compute it. Now, in America, lots of people learn a particular acronym, PEMDAS, to learn the order of operations, and that PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. So someone who has memorized that acronym will first do the computation inside the parentheses, the 1 plus 2, and replace that with a 3. When they reach the point of 6 divided by 2 times 3, they think, multiplication comes next in my PEMDAS acronym, so I should do the multiplication. 2 times 3 gives me 6, and 6 divided by 6 is 1. However, if you were to type this into a calculator or computer, you would get a different answer, an answer of 9. The first step that the computer performs is exactly the same as what a person performs. The 1 plus 2 gets replaced with a 3. However, the computer first does the 6 divided by 2 and replaces that with a 3, and ultimately does that final multiplication to arrive at an answer of 9. And then this ultimately leads to lots of screaming and people tagging me for my quote-unquote expert opinion on this, and it turns into a big old fight. So what is going on here? Well, although PEMDAS is the acronym that's very frequently taught in American schools, in other parts of the world, students are taught an acronym called BODMAS, standing for brackets of, like taking the square root of, division, multiplication, addition, subtraction. The reason I bring it up is to emphasize that there's room for some sort of debate or there's some type of miscommunication going on. The reality of the situation is that if I were going to put an acronym on this at all, I really like this acronym of GEMS. Because it is true that parentheses or brackets or grouping symbols, whatever you want to call them, have the number one precedence. It is equally true that exponents or roots or of have number 2 precedence. But when it comes to multiplication and division, these symbols are tied in the hierarchy, meaning that we don't always do multiplication first or always do division first. The multiplication and division operations have equal precedence, and so the tiebreaker between the two of them is which one is the leftmost. A similar story is true for addition and subtraction. Addition and subtraction are tied in the hierarchy of precedence, and so the one that gets precedence between addition and subtraction is whichever one appears leftmost in the expression. So you need to be aware of this true order of operations to know precisely the computation that you're doing. Now the real answer, other than 1 or 9 to this problem, the true college answer and the real mathematical answer is, if it's causing this much debate, you're not writing it clearly enough. And there's no harm in adding additional brackets to make your intention clear. So the only reason that something like this exists is because somebody has very poor communication skills and not just that order of operations is that difficult. But because this can create problems, I wanted to make sure we covered it.